Is the built-in hash method of Python 2.6 stable across architectures? I need to compute a hash that needs to be stable across architectures. Is Python's hash stable? To be more specific, the example below shows hash computing the same value on two different hosts/architectures. The above is true for at least those inputs, but my question is for the general case.
If you need a well-defined hash, you can use one out of hashlib.
The hash function is not what you want. Finding a reliable way to serialize the object, e.g. str or repr, and running it through hashlib.md5, would probably be much more preferable. In detail, hash is designed to return an integer which uniquely identifies an object only within its lifetime. Once the program is run again, constructing a new object may in fact have a different hash. Destroying an object means there's a chance another object will have that hash in the future. See Python's definition of hashable for more. Behind the scenes, most user-defined Python objects fall back to ID to provide their hash value. While you're not supposed to make use of this ID obj, and thus hash obj is usually implemented, e.g. in Python, as the memory address of the underlying Python object. Thus you can see why it can't be relied on for anything. The behavior you currently see is only reliable for certain built-in Python objects, and that not very far. Hash, for instance, is not possible. Regarding hashlib.md5 strobj, or equivalent, you'll need to make sure strobj is reliably the same. In particular, if you have a dictionary being rendering within that string, it may not list its keys in the same order. There may also be subtle differences between Python versions. I would definitely recommend unitists for any implementation you rely on.
No. If you need a stable hash, create a digest of your data using something like SHA-1, which can be found in hashlib.
No. On ARM with Python 2.6. 89,902,565